In this video, we're going to use PerfView to investigate the .NET GC heap and do a memory investigation. The application that we're going to use for this demo is Visual Studio. So you can see that I've launched Visual Studio and I've brought it to a point where I think it's interesting to look at the GC heap. But before I actually collect the data with PerfView, I have to realize that PerfView is only going to show me about the GC heap. And so I have to have some idea that tells me that that's a good idea, because maybe my memory is all being consumed by something besides the GC heap. And to determine that, I'm going to use a different tool. I'm going to use a tool called VMMap. And this is a sysinternals tool. It's a free tool that you can get by downloading from the web. Just Bing it and you'll find the download site. And when you launch it, it will bring up this dialog box where it's basically asking you to select a process to dump. And so I'm going to select the Visual Studio process, which is this devm.exe, and it brings up this view. And what this view is an all-up view of all the memory that's being used by this process. And the important parts of this view is this bar right here and this table up at the top. This bar is the working set bar, and it's a graphical representation of this column. And these are the categories of memory that the application's memory usage has been divided into. So you can see that this instance of Visual Studio was consuming 403 megabytes of memory, and it was broken down into these various categories. So in fact, 168 megabytes was images and so on. The one that we're interested in is this one right here, and we see that about 39 megabytes, 39 megabytes of memory is in the managed heap. Now that's not all GC heap, but most of it is. And so what this tells us is that, interestingly, less than 10% of the total memory usage of Visual Studio is being consumed by the managed heap. And so this really shouldn't be the first place we look to go after memory optimizations. There are definitely other things that are more interesting, like the unmanaged heap or images, and you can see how big those are in comparison to the .NET GC heap. But having understood how big the GC heap is in relation to the other things, we can now take a look at what's going on inside that heap. And for that, I'm going to launch PerfView, and I'm going to use the memory take heap snapshot command. And it brings up, again, another dialog box that sort of is asking what process you want to do. And I'm going to type a few letters of the process name, and you can see that filters out all other any other process that doesn't have those letters in its name. And so I can quickly get to the point where I've selected the Visual Studio process. But before I do select it, I want to call out a couple things. And the first thing is this line over here. Sometimes you'll find that you don't find the process that you're looking for, and it's typically because you're not elevated. PerfView can only show you the processes that it has access to, and if the process that you're interested in is some server process, there's a pretty good chance that it's running as something besides your credentials, and because of that you need to be admin in order to dump its GC heap. The other thing that I wanted to show you was this freeze button. By default, when you dump the GC heap, the PerfView does not does not freeze the process. So it lets the process run. And there's a very good reason for that. The reason is that we want to allow you to dump on live production machines. So if you have a service that's running in production, you don't want it to take 10, 20, 30 seconds of frozen time when it's not actually responding to requests to dump the GC heap. By not freezing the process, it does mean that the heap is changing over the time that the dump was taken, and so it's not going to be a perfect dump, but it'll be 90% good, and it'll be accurate to maybe at least 90%. But on the other hand, you don't have to stop the process, which means that you can get real live production data. If you really want that perfect dump, you can click this freeze button, but most of the time it's not necessary. So I'm going to go ahead and click the Dump GC Heap button, and you can see now it's working. It's trying to dump the heap, and you can also see that it's not like an instantaneous thing. And if this were a 10 gigabyte heap or a 20 gigabyte heap, it would take a minute or two at least to dump the heap. This case, the heap was only 34 megabytes, and because of that, it dumped it in 10 or 15 seconds. It created this file called devm.gcdump, but then it immediately opened this viewer on that file. And this viewer looks remarkably similar to the CPU viewer, the stack viewer. In fact, it is effectively the same viewer, but instead of measuring milliseconds of time, it's measuring bytes of memory. And so, but you use it in a very similar way that you use the CPU viewer to do an investigation. And in particular, you always start by looking at these top-level statistics up here. And you'll see that that in here, in this particular dump, that I dumped 34 megabytes of GC memory, and that it took 632 kilo objects, 632,000 objects to add up to that 32 megabytes of memory. The other thing I wanted to call your attention to is the rest of this line. It says the heap has been sampled, and that the mean count multiplier, the count multiplier, is a little over 10. And the reason for that is that PerfView is designed to deal with very, very large heaps, gigabyte heaps. And if you dealt with gigabyte heaps and you didn't sample, you would end up with very large files that would be very painful to transfer, as well as painful to view, just because of the volume of the data. So what PerfView does is, at collection time, it takes all of the heap and it grabs a perfect fidelity copy of it, and then it does a sampling of that copy. And because it has all of the information, it can do a very good job of picking good samples for that sample that it's going to take. And if you want to know exactly what it's doing to produce that sample, all you have to do is click the Understanding Perf Data help link, and then go to the sampling link, and it will describe in fair detail exactly what the algorithm that PerfView uses to do that sampling. You can also open up the log and get information about the sampling that it did and exactly what went wrong, if there's anything that went wrong during the heap dump, as well as the original statistics associated with the sample, as well as the final statistics. But hopefully you will never need to worry about that, because this view is designed to look like it's the view of the unsampled thing. That is, it looks like the whole heap. All of the numbers in this view have been scaled so that it looks like the whole heap. It's just faster and smaller as far as sampling the data. At this point, you're pretty much ready to start your investigation of a .NET memory, the memory usage of your .NET application, and that is a topic for the next tutorial.